Hello and welcome to another one of these ADD videos. Today we're going to look at an intermediate example of using double integrals to find area. So if you remember, you can use dy dx or dx dy. Some instances it'll be better to do dy dx, others will be better to do dx dy. It just depends on the problem, and we're actually going to address that in this video. Here is stating the rule that the inner equation, the inner integral, when I'm writing an integral, should be an equation of the line, whereas the outer integral is the highest and the lowest, either y or x value. Here's our example that we're going to look at. You can see that there's only y given. There is no x values given, so what we're going to have to do is find our intersection points. The best way to do this, again, is to graph it, because now that it's no longer just straight lines, because of that squared, you're not exactly sure what's happening. And the main thing to do is graph it. Hopefully you're pausing this and you're trying to do this on your own and now checking your solution. So here's me imagining myself on the inside of this thing already, and if I look up, the question I ask myself is, does the roof ever change, or is it the same function? No matter where I am on this, in this region, if I look up, it's always going to be this x squared, right? Or 6 minus x squared. And no matter where I am in that region, and no matter where I am in that region, if I look down, what happens? I'm going to hit this x line. So what I need to do first is find my intersection points. How do I find this intersection point? Well, what's true here and here? Well, their y values are the same. So what I can do is set y equal to y, and in this case x will equal to 6 minus x squared. So at that point, if I bring it all to one side, I get x squared plus x minus 6, and then I get x plus 3x minus 2, and that's x equals negative 3 and x equals 2. So those are the x values of your intersection points, and also going to be your bounds for your integral. Always go from the smaller to the larger, and it's going on the outside because I told you we were going to do dy dx. Now the bottom bound we said was the line y equals x, and the top bound was 6 minus x squared. So now that we've done the hard part, just integrate. The integral of 1 is y, and that's going to get evaluated between 6 minus x squared and x. When I plug in, I get 6 minus x squared minus the x. That gets integrated from negative 3 to 2. And you get 6x minus x cubed over 3 minus x squared over 2. Evaluated between 2 and negative 3. So if I plug in a 2, I'm going to get 12 minus 8 over 3 minus 4 over 2. Minus 3 plugged in is going to be a negative 18. You can double check my numbers there. Okay, this is all just fractions and calculator exercise. You should be able to do it. If you're lazy, you could do it on a calculator. If you have some faith in yourself, you can maybe do it on a piece of paper. A little patience. So if you distribute that negative 1 through, you get a plus 18. Negative and negative is positive, times a negative is a negative 27 over 3, which is 9. And then minus 9, because this squares it, makes it positive. Minus 9 times a minus gives you plus 9 over 2. Let's double check that. That's right, that's right. Plus, minus, okay. That looks good to me. Common denominator 6. You get 114, 36. Let's see. Three goes into there. 29 times 2. That should be your final answer for the area. Alright, so I haven't given you anything too tedious. Now, I told you I was going to address the issue of one method would be better than the other. Why would the dy dx be better than dx dy? Well, if we were doing dx dy, we would first look at the left part of the region. What happens when you look at the left part? Well, the left part's okay. That's not the big deal. In this case, you get the same function at the left. It's the right that bothers me. Look at the right side of this region. If we were doing functions, what happens? Well, we would get two different right sides because this point right here, the right side changes. At first, it's the 6 minus x squared function. Then it's the straight line, right? So anytime it changes like that, that's going to mean you're going to have two integrals. And that's more work. So dy dx in this case is definitely better because there's no change of the top and there's no change of the bottom. So keep that in mind. The next one, I'm going to let you choose which way to do it. And it'll be better to do it one way versus the other. They might even ask you to reverse the order of integration. So you should be able to deal with graphs and go from graphs to integrals. Most important thing to do is practice, practice, practice. Thank you and have a nice day.